Hello, students. Today, we will learn about the standardized production technology of eggplants. Eggplant is an important solanaceous vegetable in China, characterized by high yield and strong adaptability. Scientific cultivation techniques can significantly improve yield and quality, especially grafting technology, which effectively overcomes soil-borne diseases. This task covers the entire process from seed treatment to field management, focusing on key technical points to help you master core skills. This task mainly involves learning about four aspects: seed treatment, grafting and seedling raising, field management, and summary and improvement. Main knowledge objectives of the task: understand the seed treatment technology for eggplants. Understand the grafting and seedling raising technology for eggplants. Master the field management technology for eggplants. Main skill objectives of the task: be able to correctly state the key points of eggplant seed treatment technology and the key points of grafting and seedling raising. Be able to formulate an eggplant management log based on the key points of eggplant production technology. Main quality objectives of the task: cultivate students' requirements for scientific experimental techniques, establish standardized professional awareness, and rigorous work processes. Now, let's first learn about seed treatment, which is a key technology for seedling raising and the foundation for raising good seedlings. Prioritize using disease-resistant torbams or wild eggplant rootstocks, which have strong resistance to soil-borne diseases such as verticillium wilt and bacterial wilt. Select varieties with good commercial quality, such as Hangzhou eggplant, according to market demand. The seeds should be plump and free of damage, and aged seeds should be avoided to ensure germination rate and germination potential. Rootstock seeds are first soaked in warm water at 55 degrees Celsius for 15 minutes to kill surface pathogens. After the warm water treatment, the rootstock seeds are soaked in a 100-200 mg gibberellin solution for 24 hours to effectively break seed dormancy. Scion seeds are soaked in a 0.3% potassium permanganate solution for 30 minutes for disinfection. After soaking, the scion seeds need to be rinsed 3 times with clean water to ensure that residual potassium permanganate is thoroughly removed and prevent the spread of pathogens. Operational steps for variable temperature germination acceleration. Variable temperature germination acceleration first requires soaking the rootstock seeds, followed by placing them in a constant temperature incubator for treatment. During the germination acceleration process, the temperature should be maintained at 30 degrees Celsius during the day and reduced to 20 degrees Celsius at night, and this temperature alternation treatment should continue for 8 days. During this period, the seeds need to be washed with clean water once a day to keep them clean and in a suitable growth environment. Environmental requirements for scion germination acceleration. Scion germination acceleration needs to be carried out at normal temperature, with the key being to maintain environmental humidity. By maintaining appropriate humidity, the germination of scion seeds can be promoted. When the seed whitening rate reaches 80%, sowing can be carried out, which is the sign that scion germination acceleration is completed. Temperature management during germination acceleration. During variable temperature germination acceleration, temperature management is one of the key factors. The alternation of high temperature, 30 degrees Celsius during the day, and low temperature, 20 degrees Celsius at night, simulates the natural day-night temperature difference, which helps with the physiological activation and germination of seeds. This temperature management method is the core of the variable temperature germination acceleration technology. For variable temperature germination acceleration, the completion standard is that the seeds undergo 8 days of alternating temperature treatment and are washed with clean water once a day. For scion germination acceleration, the completion standard is that the seed whitening rate reaches 80%, at which point the seeds are ready for sowing. After seed germination acceleration is completed, we can proceed with grafting and seedling raising. First, learn about seedbed preparation and sowing methods. Key points for seedbed substrate preparation. The seedbed substrate should be prepared in a ratio of 4 parts decomposed organic fertilizer to 6 parts garden soil, and 1 kg of compound fertilizer, and 50 g of carbendazim should be added per cubic meter to prevent damping off. Pre-sowing preparations. Before sowing, the rootstock should be sown 25 days in advance, and the seedbed should be disinfected to ensure the growth environment after the scion is broadcast sown. Sowing techniques for rootstock and scion. The rootstock should be sown 25 days in advance, while the scion is broadcast sown in the disinfected seedbed, covered with a soil thickness of 0.5 cm, and covered with plastic film to maintain humidity. Moisture retention management after sowing. After sowing, plastic film needs to be covered to retain moisture, which is to ensure that the seeds can germinate and grow smoothly. Key points for temperature and humidity control and management. Before seed emergence, the temperature of the seedbed needs to be maintained at 25-28 degrees Celsius, and the humidity should be maintained at about 80% to facilitate seed germination. Temperature adjustment after emergence. Once the seeds emerge, the temperature of the seedbed should be adjusted to 25 degrees Celsius during the day and 17 degrees Celsius at night to promote the healthy growth of seedlings. At the same time, we should take measures to prevent damping off by adding 50 g of carbendazim per cubic meter of substrate. The occurrence of damping off can be effectively prevented, ensuring the safe growth of seedlings. 2. Prevent seedling leggy growth. It is also necessary to control the daytime temperature at 25 degrees Celsius, the nighttime temperature at 17 degrees Celsius, and maintain appropriate humidity to promote strong seedling growth. Eggplant grafting methods and precautions. First, rootstock treatment. Rootstock treatment includes retaining 2 true leaves, cutting the stem horizontally, and then making a vertical cut 1 to 1.5 cm deep for grafting. Key points for scion treatment. The scion needs to be cut into a wedge shape to ensure that the incision matches the rootstock and retain 2 to 3 true leaves for growth. Bonding and fixing methods. During grafting, after aligning the cambium, use a grafting clip to fix it to ensure that there are no gaps at the interface and promote healing. Disinfection of grafting tools. To avoid infection, grafting tools must be disinfected with alcohol to ensure the hygiene of the grafting process. Matching of rootstock and scion. The difference in stem thickness between the rootstock and scion should not exceed 0.2 cm, which can improve the survival rate of grafting. Tips for improving survival rate, in addition to the above points. Grafting also needs to pay attention to the matching degree of the rootstock and scion, as well as post-grafting management, such as maintaining appropriate temperature and humidity to further improve the grafting survival rate. Key points for temperature and humidity regulation. In the management of grafted seedlings, Temperature and humidity regulation is crucial, and different temperature and humidity conditions need to be adjusted according to the time period after grafting to promote survival. Management measures for the first 3 days. In the first 3 days after grafting, a closed small arched shed environment needs to be maintained, with the temperature controlled at 28 degrees C, the humidity maintained at 95%, and full shading treatment. Management measures from the 4th day to 7th day. From the 4th day to 7th day, ventilate for 1 hour in the morning and evening. Reduce the humidity to 85%, and gradually increase scattered light to adapt the grafted seedlings to light requirements. Management measures from day 8 onwards. From day 8, remove the shading net to restore normal temperature and light conditions for the grafted seedlings, ensuring that the nighttime temperature is not lower than 15 degrees Celsius to promote the healthy growth of the seedlings. Survival judgment standard. 7 days after grafting. Judge survival by observing whether the new leaves of the scion unfold and whether the color is bright green if survival occurs. The lateral buds of the rootstock need to be removed in a timely manner. Management measures after survival. In addition to continuing to monitor temperature and humidity conditions, it is also necessary to pay attention to timely removal of rootstock lateral buds to ensure the normal growth of grafted seedlings and improve the survival rate. Next, we will learn about the field management technology of eggplants, which is the key technology to obtain high-quality eggplants. It mainly involves learning about 3 aspects: soil preparation and base fertilizer, planting management, and pruning and fertilizer, water management. Key points for soil preparation and fertilization. First, deep plowing is an important step in soil preparation, requiring a depth of 30 to 40 cm, with the aim of breaking up soil clods and removing weeds, thereby effectively improving soil permeability and creating a good soil environment for crop growth. After plowing, ridge formation is carried out. The ridge formation specifications are also crucial for crop growth. The standard is a ridge width of 60 cm and a height of 15 to 20 cm. In rainy areas in the south, to adapt to the climatic characteristics, the ridge height can be increased to 25 cm, while the furrow width is maintained at 30 cm for drainage and ventilation. While plowing, base fertilizer is added. The base fertilizer formula directly affects the initial growth of crops. It is recommended to apply 3,000 kg of decomposed organic fertilizer, 40 kg of compound fertilizer, and 20 kg of calcium superphosphate per mu after uniform spreading. Mix them through rotary tillage to ensure that the fertilizer is fully mixed with the soil and provides the nutrients required by the crops. Finally, soil disinfection is also required. Soil disinfection is an important measure to prevent soil-borne diseases. Before planting, the soil should be thoroughly watered with a 500 times diluted 50% carbendazim solution to effectively reduce the number of pathogens and protect crops from disease damage. The timing for eggplant planting should be carried out when the seedlings reach the age of 4 to 5 true leaves, and the soil temperature is ensured to be stable above 15 degrees Celsius to avoid the adverse effects of low temperature on the seedlings. Adopt a double row planting method with a row spacing of 60 cm and a plant spacing of 40 cm, which can ensure that about 2,000 plants are planted per mu to achieve a suitable planting density. Immediately after ridge formation, cover with black plastic film, which can be pre-drilled with planting holes for convenient seedling planting. The plastic film can play the role of heat preservation and weed growth inhibition. At the same time, pay attention to compacting the soil around the film holes to ensure the fixing effect of the plastic film. Pruning is a key technology to adjust eggplant growth, and the double stem pruning method is often used in production. The double stem pruning method involves retaining the main stem and the first lateral branch while removing other lateral buds to reduce unnecessary nutrient consumption and improve the overall growth efficiency of the plant. Regularly removing lower old and yellow leaves, as well as retaining 1–2 fruits in each inflorescence, and removing deformed fruits is crucial for improving crop health and yield, helping to concentrate nutrient supply and optimize fruit quality through double stem pruning and leaf and fruit thinning. The unnecessary consumption of nutrients can be effectively reduced, ensuring the centralized use of nutrients required for plant growth, thereby improving crop growth efficiency and yield. During fruit thinning, removing deformed fruits is an important measure to ensure fruit quality and plant health, helping to reduce resource waste and enhance the market value of the final product. Fertilizer. Water management is a key management technical point in eggplant planting. During the acclimation period, thoroughly water the seedlings 5 days after transplanting and apply 5 kilograms of urea per mu, laying a solid foundation for the healthy growth of the plant. After fruit setting, apply 15 kg of high potassium compound fertilizer per mu every 10 days, and spray 0.3% potassium dihydrogen phosphate on the leaves to improve fruit quality and ensure high yield and quality of the crop. During the peak fruit period, apply 20 kg of ternary compound fertilizer per mu in combination with watering to maintain appropriate soil moisture while avoiding waterlogging and ensuring the continuous healthy growth of the crop. By accurately controlling soil moisture, ensuring neither waterlogging nor excessive dryness, it helps maintain the normal growth of the plant and avoid the occurrence of diseases. To facilitate your learning of this task, the teacher has summarized this task, hoping to help you. 1. Seed treatment and grafting are the foundation for disease resistance and high yield, requiring strict disinfection and temperature control. 2. Soil preparation and bed making need to ensure soil looseness and drainage, and deep application of base fertilizer improves fertilizer efficiency. 3. Post planting management needs to balance fertilizer and water supply and optimize plant structure in combination with pruning. Students, by mastering these technologies, the mu yield of eggplants can reach more than 4,000 kg, with significant economic benefits. After class, each group is required to design an eggplant production calendar marking the operation time of each link, transforming theory into practical ability. Thank you all.